Hello everyone, this is Dr. N.G. Praveena, working as Associate Professor in the Department of ECE at R.M.K College of Engineering and Technology. In this video lecture, I am going to discuss about the concept of adaptive delta modulation. What is the need of adaptive delta modulation? In ADM, the step size is made variable based on the variations of the input signal x of t in order to overcome the noise which is produced due to slope overload and granular distortion. It is called as adaptive delta modulation in the sense during the steep segment of the input signal the step size is increased, and when the input signal is varying slowly the step size is reduced. Further, ADM is classified into continuous and discrete ADM based on the step size adjustment. It is said to be a continuous ADM when the step size variation is done with the continuous set of values. In discrete ADM, the step size variation has done with the discrete set of values. It shows the waveform of adaptive delta modulation. Here there are two step size variations has been represented. One is del 1, the other one is del 2. When you observe the step size, obviously del 2 is greater than del 1. Here the input waveform is steep, it is a steep segment, so the step size is increased. Here the input signal is changing very slowly, hence the step size is reduced. So del 1 is less step size, where del 2 is large step size. The same concept applies here. When x of t is greater than u of t, 1 is transmitted. When x of t is less than u of t, 0 is transmitted. This shows the transmitter block diagram of adaptive delta modulation. The transmitter block diagram consists of the comparator block, a quantizer block, an accumulator block, and a logic for step size control. The sampled signal has taken as x of nts and its last approximated signal has taken as x cap of nts. It is given to a comparator. The comparator compares the sampled signal and its approximated signal, and the output of the comparator is written as E of nts, where E of nts is equal to x of nts minus x cap of nts. It is given to a quantizer block. The quantizer generates V of nts. So V of nts is either plus delta or it is minus delta. When x of t is greater than u of t, it is plus delta. When x of t is less than u of t, it is minus delta. This is applied to an accumulator block. The accumulator has a summer in the path. So this is going to add the quantizer output and the delayed version of your sampled signal u of n minus 1 ts. So the output of the summer block can be written as u of nts. Mathematically, u of nts can be written as u of n minus 1 ts plus v of nts. Since it's delayed, this is your approximated signal and you get an error. Finally, it is quantized. This is similar to that of your delta modulation transmitter block diagram. But based on the step size variation, when this for the steep segment and for the slowly varying segment, the delta has to be changed. It is not a fixed quantity. So the output has been taken as an input for a logic for step size control. So, based on the variations, the step size is controlled, and based on that the quantization has been done here. Mathematically, the equations has written for the step size. Del of NTS is the step size variation. The minimum limit and the maximum limit for the step size is del min, and the maximum limit is del max. Whereas del max is the upper limit which controls the slope overload distortion, whereas del min is the lower limit which controls the channel noise. The del of NTS is written by applying an adaptation rule. Since it is going to adapt as per the x of t, it has been written as g of NTS into del of NTS minus Ts. The adaptation rule has been written in order to make the step size as a varying parameter. G of NTS is the multiplier term. It depends upon the bits B of NTS and its previous bits B of NTS minus Ts and so on. So, mathematically this G of NTS takes two values, one is K, the other one is K minus 1. It takes a scaling factor of K when B of NTS is equal to B of NTS minus Ts, and it takes K inverse when B of NTS is not equal to B of NTS minus Ts. The scaling factor K can be taken as a value of 1.5 for processing the speech and the image signals. For the speech signal and for the image signal, the value of K is considered as 1.5. This shows the receiver block diagram of adaptive delta modulation. Here, the first part generates the step size, logic for step size control. It generates the step size for the input. For each input, this logic size for step control generates the step size. The previous input and the present input decides the step size. It is given to an accumulator block. This is your accumulator block. It builds the staircase waveform based on the present input and the previous input. Finally, it is given to a low pass filter. The low pass filter smoothens the staircase waveform and hence it reconstructs the signal. Advantages of adaptive delta modulation. ADM is having high signal to noise ratio. Since the slope overload distortion and the granular distortion is reduced to a greater extent, and thereby it produces high signal to noise ratio. And it has wide dynamic range because the step size is a variable one. It utilizes bandwidth in a proper manner, and it eliminates the need of word framing. We are not going to transmit as many bits like PCM, DPCM and all. We are going to transmit only one bit for one sample. Thank you all.